Hello, and welcome to our fifth and final section of Chapter 1, Angle Relationships. And on the front page, hopefully you have this all caught up, but in case you don't, make sure you fill this out. For me, it obviously might be different from you, but this will start on page 8. So without further ado, let's get into it, and this is our final section of Chapter 1, Angle Relationships. Now, the first definition, and obviously we're going to be talking about angles, multiple angles, because we're talking about the relationship between angles. And this first definition is called adjacent angles. Now, adjacent, if you know what adjacent means, it literally just means next to. So if you want to put this in quotes, you could underneath adjacent. And let's go ahead and draw a diagram first. Let's just draw any big angle. Let's go ahead and put some names here, or letters. Actually, we don't even need letters. Let me rephrase that. I'm going to make this so that it does not look like it's an angle bisector. And so it's clearly two different sizes, and that's perfectly fine. And I'm actually going to label this first one angle 1, and then the second one angle 2. Now, adjacent angles, like I just stated, literally means next to. And you could hopefully clearly see that these two angles are next to each other. That's exactly what this is. The formal definition is a little long, it's a little lengthy, and all it's saying is two angles that have a common vertex. So you can clearly see the vertex is here. A common vertex. Vertex, and a common side. So here would be the common side. They both have that they both share it. But no common interior points. Now, this last part is not terribly important because it doesn't come up very often. Interior points would just be points that are on the inside. So this won't really come up. The more important part is that we have the same vertex and we have this common side. They both share this middle point, or this middle line and this middle point, the vertex. So that's our vertex. And we could say angle 1 and angle 2 are adjacent. Adjacent angles. If you want to put the angle symbol, you could. That's perfectly fine. So that's our first definition. Adjacent. Literally just means next to. You have two angles that are next to each other. Now, linear pair is our next definition. And if you, that's not spelled right, linear pair. If you look at the root word here, it's line. Linear just means line. So let's go ahead and draw our diagram first. And we're going to just draw a straight line. And I'm going to draw another ray coming from this particular point. I'm going to label the first one angle 1, angle 2. If you want to put the dashes, you absolutely could. Not completely necessary, but sometimes it's nice to know that they're not equal to each other. And a linear pair are literally two adjacent angles. So right away, we're using our first definition that form a straight line. That form a straight line or straight angle. Form a straight angle. So, in other words, it just makes a line. Angle 1 and angle 2 are a linear pair. Yep, we could squeeze this in here. Linear pair. Also, if you think about it, angle 1 plus angle 2 should equal, since it's a line, it should equal 180 degrees. Okay? And that actually stems into our next definition. Okay? and that is supplementary angles. Supplementary angles. Very much related to linear pair. You'll see what I mean. Now, supplementary angles are very similar to linear pairs. We could actually use the exact same diagram from above. If we wanted to, we could. I'm going to draw the same, almost the same one. Angle 1, angle 2, where angle 1 plus angle 2 is equal to 180 degrees. You could also say supplementary angles. You could have two different angles here. Let's call this 30 degrees. And then I'm also going to draw another one that is not connected. And I'm going to call this 150 degrees. And notice, let's call this angle 3 and angle 4. Angle 3 plus angle 4 is also equal to 180 degrees. So hopefully you caught on by these diagrams. Supplementary angles are two angles whose sum add to 180 degrees. So it's very close to linear pair, but linear pair has the definition adjacent in it. Supplementary is not necessarily adjacent. It can be, but it's not necessarily. Adjacent angles. So this is why we have the second diagram here. Okay. So complementary angles are kind of like supplementary angles, but it's not 180 degrees. So complementary angles. Now, if it's not 180 degrees, what's another important angle that we talk about? Well, hopefully you catch on by this diagram. This should be a dead giveaway. 90-degree angles. Okay, so I'm going to draw just a random ray here. Let's call this angle 1, angle 2 again. We could also say angle 1 plus angle 2 is equal to 90. Okay, we could also use a second diagram, and I probably should have put this over in the middle. We could also say something like this. Let's call this 3. Let's say this is 40 degrees. And then let's draw another one. Let's say this is 4. And this is also 50 degrees. Notice 40 plus 50 is equal to 90. So we could say angle 3 plus angle 4 is equal to 90. Oops, I forgot to put the degree symbol. And with those diagrams, it should be pretty clear. Complementary angles are two angles whose sum adds to 90 degrees. And just like supplementary angles, these are not necessarily next to each other, not necessarily adjacent. Okay, so complementary. The way I personally remember this, C comes in the alphabet before S. C is 90, or it's smaller, or it comes sooner, so it's 90 degrees. S comes later, it's 180 degrees. I do it alphabetically. However you want to do it. You could also think of C is a corner. You could clearly see a corner here. So it's a 90-degree angle. That's another way to think about it. Okay? We have two more definitions and then we're done. Vertical angles. This is going to be an important one. We're going to talk about vertical angles a lot. I would even put a star next to this one. Vertical angles occurs when we have intersecting lines. So if I were to draw two intersecting lines, we're going to have two pairs of vertical angles. And I'm going to actually label this 1, 2, 3, and 4. Okay? Something interesting happens when we have intersecting lines, and that is vertical angles. Vertical angles are formed when two non-adjacent angles, pretty much when you have, how to phrase this, their opposite sides are congruent to each other. So for instance, 1 and 4 are opposite of each other, they're across from each other. 2 and 3 are across from each other or opposite of each other. And that means they are congruent to each other. So if you want to, I'm going to put one marker for 1, one marker for 4. I'm going to put 2 markers for 2 and 2 markers for 3. So vertical angles are when we have two intersecting lines, opposite angles are congruent. And I'm just going to go ahead with the congruent symbol. They are congruent. When we have two intersecting lines, the opposite angles are congruent. So angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Okay? So, vertical angles are congruent to each other. That, by definition, is the one across. Opposite angles. If you also want to view it this way, you could kind of think of this as an arrow as to the angles in which they're pointing to each other. That means those two are equal to each other. You could view this vertically as well, pointing up, points down. They're pointing at each other. That's how you could tell they're vertical angles. Those are opposite. Those are the congruent angles. Okay. Last definition, and I'm going to need this extra space here. And this definition is called perpendicular. You probably heard of this before. Perpendicular angles. Perpendicular angles, I probably would put a star next to this one because we're going to use this a lot as well. And they are when we either have lines, segments, or rays that intersect. So just like vertical angles, but they intersect very specifically, that intersect and form right angles. So once again, right angles are 90-degree angles, in case you forgot. And here's a quick example. If we have some kind of line here, we could have a line that goes straight down. As long as it has that square, it is a perpendicular line. Okay, so for instance, I'm going to put some letters here. I'm going to say this is C, and then this is A, and this is T. Okay. Now, AT is a line, and then AC is a ray. So we could say AT, and this is the symbol that we use. This is for perpendicular. Perpendicular. That's a symbol. And you could literally see it looks like it's a perpendicular line. That's how they came up with it, this symbol. And anytime you see that, it means perpendicular. Is perpendicular to AC. Okay? And if we even wanted to extend this and make this as a line, you absolutely could. And yeah, that's pretty much it. So if you see this, it literally means we have a 90-degree angle there. Okay. All right. So, yeah, that's about it. If you do have any questions, please ask. Other than that, we'll go over the practice, and I'll see you in the next one. Bye.